So thank you for the introduction. So my name is Philippe Giordo. I'm coming from Bordeaux in the Potok team at INRIA, and today I'm presenting CARD, a mixed reality interface for collaborative learning at school. And I've done this work with Alexis Orly, Juan Solro, Stéphanie Flake, David Berthelot, Robin Vian, and Martin Haché. So let's talk about the context. So when we want to do a group activity at school, we have two type of activity, two main ways of doing it. Either children are gathered around a table manipulating paper, and the second way of doing it is to use a computer. So children are in front of a computer screen, WIMP interface, and they are doing the activity like that. For the first type of activity, children are around the table. They are manipulating really easily the content. So it's paper and the information is printed on it, and it's also well established. But the content is really static. And in the second type of activity, the digital one, the content is really dynamic. You can have videos and other type of dynamic documents. You can use it for all kind of subjects. But we have the interface is kind of a bottleneck, and you can see in the picture actually children. There is only one or two children that can interact with the computer, and the rest of them are behind and passive. And we know that for being we have to be active in the task in order to learn a better subject. So what if we could actually create a new hybrid environment where we could combine those two environments into one hybrid environment and take the both strengths of each kind of activity. And this is what this talk is about. So a lot of work has been done on fostering collaborative learning with multi-touch tabletop. But for us, it was not really an option because when we ask teachers about what we should do and how we should implement it in classroom, they told us a few things. First, we should use paper-based resources. We should allow children to have a very open degree of manipulation. So basically, they should be able to move around and do whatever they want with their hands. And then they said, please, not too expensive. So that's why we didn't went for multi-touch tabletop, even if the literature use a lot of this interface, and we went. So after that, we thought that maybe we could use projection plus touch tracking, but it's not really suited for such users that basically use their hand everywhere on the table, and so it would have been a nightmare for children. So and to interact with the setup, and also for the algorithm to detect touch. So instead of that, we decided to focus our design around tangible tokens and paper, and to avoid such kind of manipulation with touch. So going for tangible interfaces allows us to benefit from the interesting properties of tangible user interface. For instance, physical interaction have the potential to reduce the level of abstraction and facilitate learning, promote a more active engagement in the task through manual activities, can facilitate the understanding of complex or abstract concepts, and when you use augmented reality, it can even have a positive influence on learner with low spatial abilities. So augmented tabletop has already been used in education for a while now, and among them we can cite TinkerLamp that is used by vocational students for to learn how to manage a warehouse. And Illuminati Ignite, that I know, I'm sure everyone knows this interface from Ishii and Underkoffler, that helps to understand optic phenomena. So, but this type of tangible of interface use tokens, and those tokens are often really too much domain specific. So instead of that, we went for as the opposite to tokens, we have Paper, and so Paper is quite generic and can be used to manipulate any type of digital document, nearly I mean a lot of type of digital document, and in a lot of different ways. And you can see here an example for with PayPart. This is an interface that in that case provide a physics simulation, and we can manipulate the physics simulation through papers. And so with a line that we draw with a marker, we can manipulate really easily the physics simulation. And Paper also worked well with collaboration. We can put a lot of paper on the table, and people can manipulate it really easily. And this is what is done with in the case of Dynamic Land, where several papers can work together in the same time and interact in the same time with the technology. And of course, children use paper every day, so it's really good to have a medium that is to use a medium that is already used in classroom. So then, from the literature and requirement plus discussion with teachers, we created cards that stand for collaborative activities based on the real and the digital superimposition. CARD is a mixed reality system that creates an hybrid environment inside the classroom around the tabletop, where we can manipulate physically digital documents such as picture, videos, and text. So with cards, we can cards allows to user to explore a set of data, specialize them on the table, group them to form a group and to organize the set of data, and then at the end of the session, they can even create a mind map. And in that picture, you can see the result of a 30-minute activity with cards during one of our experiments at school. So children did that actually. So in the paper, I'm talking about three things. I'm talking about first the system implementation, how we use a spatial augmented reality setup to create the hybrid environment. So using a camera, a normal video projector, and a e-beam. We are talking about the iterative design and experiment and their results that we did with 136 children and 6 teachers. And then we are talking about the design of interaction, and in this presentation I will mainly talk about the design of interaction. And if you want to know more about the interactive design, I recommend you to read the paper which explains in depth the process. So the basic atom of cards is a paper sheet that hosts digital content, and with this with card, so there is a printed marker on it and a white space on the side, and with this card we can manipulate physically digital documents such as text, video, or picture. An interesting fact, actually, when we asked to a group of children if they saw any difference between printed images and augmented cards, they said no. Actually, they did not notice the video projector that was above the table, and that's only after that we show them the video projector. They said, yeah, of course it's digital, but there is no difference to manipulate either the card or those type of card or printed papers. Then children at some point want to create group of documents, so they can organize them physically, put it on the corner of the table, or they can use folders. So then we created augmented paper folders that basically host several cards, and thanks to the augmentation, we can on the first page we can project thumbnails of what is inside the content, and it avoids children to open it again and to look again inside the folder. And an interesting interaction that is particularly useful for mind maps is to create links. And so for that we use an eBeam Stylus Plus that basically controls the mouse pointer, and with that pen we can create dynamically line between object links, and we can also erase them with a similar interaction by cutting the link. And one thing that is really important for about this feature is children can do a lot of try and error that they cannot do in the normal paper activity with static content. So to expand the possibility of cards, we have created a new type of interaction that lets user customize the object and look inside the documents. So the first one was a Magnify token that was used to zoom inside a digital content or a folder. And the second one was a text entry token to rename or to name a document. But at some point we couldn't add more tokens, and we were losing the advantage of the physicality. So we asked ourselves, how can we go further without multiplying those tokens? And the answer to that question is the inspector. The inspector is in charge of basically all digital interactions of and modification of digital property of documents, and it regroups all interactions that could be done and that are normally done in a WIMP interface. So currently with the inspector we can do three things. We can name a document. We can explore. So to name it, we reused the magnifying tokens, and with a wireless keyboard, we can type and then name an object, link, so it can be a card, folder, or links. And then we can also, as you can see in the video, change a digital property of an object or a link, and then we can also explore what's inside a card or a folder by using the pen, and then yes, we can rename also folders. So this is an example on how the inspector is used during an activity with children. Okay, so the sound is not coming, but so anyway, you first note that on how children interact with a card. So they are exchanged like a normal piece of paper, and there are a lot of manipulation in 3D and not only in 2D that we could expect. And the inspector is centered on the table, and it's used as a mediation tool between students in order to they are basically forced to collaborate by using this inspector, and to wait and to look at every picture that a student want to explore. So to conclude, in the following in the coming days and weeks, we will deploy a 12 card system in classroom in order to see what's really happening when we are not here. Our teacher will use them. Will use those kind of setups, and then starting from January, we will extend use cases and to take into account French, English, German, history, geography lessons, and we plan also to expand the hybrid environment to other objects found in classrooms such as map and books. Thank you very much. If you have any questions, don't hesitate, and I let you see the paper for more details. Thank you.
Thank you. Questions?
Do you have any target group, age group? It could be, although you are concerning with users as children, if they are younger and older, they might behave differently or use different way. So, do you have any, any other experience or something you can share with us?
Yeah, exactly. So the target age is between 8 and 13 years old. So actually, we are working with 7 different classes. So between those age, and so we mainly target the use of cards in that area of. So with those children, and so that's it. I don't know if I answered well to the question. Yes. Okay.
Hi, Tim Dwyer, Monash University. It's a really nice system. I noticed that the fiducial markers are quite prominent on the cards, and I wonder, are the markers always associated with a single digital artifact, or are they
with a single what? Sorry.
With a single digital artifact, like does the marker always mean the same thing throughout the activity, or do they get reused in different contexts? And what's
actually for cards? Thank you for the question. Actually, for cards, for the cards in the table, so we have a set of markers that are dedicated to the card, and we have a set of markers that are dedicated to folders. But at the beginning of the activity, and at least it depends on the activity, but in the last one, teachers wanted to let children associate each images or videos, each digital element to a card. So there were no basics. There were no. We did not associate each media to a card, but we can do it. It's just a checkbox to check at the beginning of the application.
Well, just a short question.
Thanks a lot for your wonderful presentation. This is Amit from IIT Gandhinagar. And since you have used Aruco markers for localization, and these are limited markers, like maybe around 256 you can use, and each of that has a unique ID, and your target group is children. So there are chances that it may get damaged, and the localization may not be possible. And in that, so have you thought about some method about the overcoming the limitation of these markers?
I don't really get the question. Can you repeat it? Sorry.
So these fiducial markers that you have used, the Aruco markers, they are limited, and they have to be a unique mapping for them. And since your target group is children, there is a lot of chances that they may get damaged during the task. So have you thought about any method how you will overcome these kind of limitations of the Aruco markers itself?
I'm not sure to
understand. So what he's asking is, are you considering something other than the fiduciary markers? Are you maybe in the future work because?
Yeah. Okay. Thank you. Actually, not really. Children are not too. It's the markers don't bother children at all. So they are. We don't have many feedback on that. So we don't really consider to change that. But maybe if we have a better tracking tracking feature, we could change for other things. But it's a quite large space, and we are using a single camera because we want it to be quite cheap also, even if it's not a requirement. But so no, we are not considering changing it for now. Thank you.
Thank you. Help me thank Philip and all the previous presenters, please.